Okay, in this lecture, I'm going to go over the Word worksheet and the Excel workbook. If you haven't done so already, go ahead and go to Canvas and download the Word worksheet and the Excel workbook. That's the exact same Excel workbook as what you already had from week 1. So if you already downloaded it, don't download it again. Just keep on doing the same work in the exact same Excel workbook, and then the Word worksheet as well. So I'm going to go ahead and pull up the Word worksheet and just go through this, make sure that you thoroughly understand how to do all of this. And so we have defined sampling and why populations are sampled. So you're doing all of this information right here. And then so these are the reasons for sampling coming down here. These are the different methods of sampling. And so there's convenience, cluster, simple random sampling, stratified, systematic, and there's videos that go over this as well. And then right here it says state the best sampling strategy for each one of the following scenarios. So a researcher is examining ticket sales for a concert that would like to take a sample to find the average price paid for tickets, whether directly from the venue or resale like StubHub. The researcher wants each ticket to have an equal chance. So that right there, that's the key word there, have an equal chance of being selected. Everything has an equal chance. It's just simple random sampling, because it's like putting everything in everyone's name in a bowl, and you just grab it out, and that's simple random sampling. Okay, and then coming through here, a lot of people get confused, and I'm just going to say this really quick, between cluster sampling and stratified sampling. Cluster sampling is when a population is divided into clusters using naturally occurring geographic or other boundaries. And so what I normally say here is this is qualitative groups, groupings, and this tends to be quantitative. And so you split them up into strata, or you split them into clusters. And so depending on who it is that you talk to, they're going to do different things with it. Also, the book, if I'm not mistaken, it mentions that stratified random sampling takes proportionately from each strata. So depending on how large the strata is, I think it says that it takes it proportionally from each strata. But all that I'm really going to emphasize is that cluster sampling focuses on qualitative groups. In other words, like freshman, sophomore, junior, senior, where stratified random sampling takes, 10 to 20, 20 to 30, 30 to 40. And so you break them up into strata, and we'll go from there. So coming down here, you got to finish all of this information, and then the college wants to know how many hours a week their students study per week on average in relation to their college work. The college samples students based on no job, part-time job, full-time job from a previous survey. So what you're coming down here, you're doing the exact same thing. It's just, it gives you, different scenarios of how they would sample them. And so just keep doing the exact same thing. Okay. Then next, assess the context of the needed data and develop appropriate plan for sampling. Okay, the students would like to, the school would like to take a sample of students to determine students' average GPA. The school wants to use stratified sampling. So what is it that you should do? So look up here, and should you look at, say, freshmen, sophomore, juniors, and seniors? Is that a strata? Or maybe 0 to 1, 1 to 2 with their GPA right here? What is a possible strata? And you might want to consider, I don't know, maybe their GPA, because these are strata that you split up. Okay. How many would you need from each strata if you needed to sample 150? So I'm going to show you really quick how to do this, because you're going to need to do this in the future. So I'm going to go ahead and copy this, Control C, and I'm going to go into Excel. So I'm going to go File, New, and I'm going to put this right here. And so I need a total of 150 from each strata. So the first thing that I'm going to do is I'm going to find the total in each strata. So in order to do this, I do equals sum, and I add up all of these values. So sum parentheses, and then I highlight all of them. and then you can just drag them down. So now you know you've got 37 in this group, 144 in this strata, 295 in this strata, and 324 in this strata. So if I want to find what is how many I should sample from each one, what you need to do is you need to first find the relative frequency of each strata. Okay, so we're going to come right here and we're going to get the relative frequency, which this is driving me nuts. There we go. The relative frequency. And so we're going to do equals, well, first we're going to do equals sum. Okay. And so the sum is 800. There's a total of 800. So we're going to do equals 37 divided by 800. Okay. So that's 4.65%. And then you can just drag it down. So now it's 144 divided by 800, 295 divided by 800, 324 divided by 800, and then obviously 800 divided by 800. I didn't mean to do that, but if you add all these up together equals sum, you're going to get a total of 1. And so now you see this is the relative frequency of each one. So if you want to know, hey, I need to sample a total of 150 and I need to take proportionately from each one of these strata, what you do now is you do equals 150 multiplied by the relative frequency. So it says take 6.9 and then you drag it down, take 27, take 55.3, take 60.75. So this is what I'm going to do. I'm going to round this up and I'm going to say take 7, take 27, take 55, and take 60, 61, and then that should equal 150. And so what I did is I found the relative frequency, then I did relative frequency multiplied by 150, and then I did round the previous one. And so I rounded it up or down to get to the 150. So the answers are I need 7 from 0 to 1, 27 from 1 to 2, 55 from 2 to 3, and 61 from 3 to 4. Okay, so let's take a look at this. What is a possible strata? GPA. How many would you like to take from each strata? So list out each strata. So I'm going to control C. Let's see here. Control C. I'm going to go like this. Control C. And I'm going to. No, I didn't really like the way that looked there, but well, I know why I did that. Table design. Let's make it pretty. There we go. And now you have your answers there. Okay, the school wants to use systematic sampling after putting them in order from youngest to oldest. Choose a term for K if I want a total in my sample. So total of 100 in my sample. So what does K mean? That's a really good question. K means the you need to choose every kth person, right? So if you need to, if there's a total of 800 and you need every kth person, if you will, what you do is you say, okay, I need equals 800 divided by, we need 100, 100. And if I take every 8th person, so A would be my K, 8 would be my K. If I take every 8th person that from the entire sample of 100, or from the entire population of 800, it will give me a total of 100. So right here, if I want a total of 100 in my sample, then I need a total of, K needs to be 8. So because 8 times 100 equals 800. So if I sample every 8th person, I will get a total of 100 in my sample. Okay. So a school wants to use cluster sampling. Clusters are naturally occurring qualitative classes. What clusters should the school use? And so I would say classification. Okay. If I want a total of 100 in my sample, how many would you sample from each of the clusters? So in other words, list out the clusters. So, and how many you would need from each. This is a lot easier. So freshmen, sophomore, junior, senior, and we would need a total of, for if we want an equal number, we would need 25, 25, 25, and 25. There we go. Then the school wants to use simple random sampling. What's one way that you could do this? There's a lot of ways you could do this, and I'd suggest you find your own way to do this, but you could put all their names in a hat and you could pull them out. You could list all of their names in an Excel spreadsheet and you could use a random number generator. So just put something down there, but make sure that you understand why it's simple random sampling. Okay, a school wants to use convenience sampling. How could this be done? You could put somebody at the front door and you could say, hey, choose randomly the people that are coming through the front door. You could say, tell every teacher to send 5 kids to the office. It's whatever's convenient, and that's really what it is. It's just whatever's convenient, and there's so many different ways to do it. Okay, and so you're going to be doing something similar with the next two, and so I gave you this example right here, so that way it'd be really easy for you to do the next two. And then assess the context of the needed data to develop appropriate plans for sampling. So what are 5 reasons? Give an example when someone would use clustering, so and then define sampling error. You know what? Don't do this. Or do I want you to do this? No, I don't want you to do this yet. I don't think that I do. Well, maybe. All right, sampling error. Let me just really quick go over this. Yeah, go ahead and do this. But sampling error, all that it means is that when you have a sample mean, so in other words, I take a sample of 100 people, the sample mean that I got, their average was, hey, I spent 14 minutes getting ready for school this morning, where the population mean is 15. So 15 minus 14 means that the sampling error is 1. 13 minus 14 means that the sampling error is -1. And that's really all that it is. It's the question is, sampling error is, what is the difference between the population and the sample? Okay, that's it. So what is the difference between the population or the population parameter and the sample statistic? So sampling error defined is, what is the difference between the pop parameter and sample statistic? There we go. Gosh. Okay. And then coming down here, look in your book on experimental design. I'm not going to harp on this too much, but just read through that, and then it'll give you more information on what experimental design is, placebo, treatment, blinding. There's going to be some questions on that. And then the difference between an independent and dependent variable, and then just fill this in. So blank variable causes change in the blank variable. So just put independent here, or, whichever one is supposed to go. So independent and dependent are supposed to go in those 2 blanks. And so that's what it is for the first worksheet. And let's look at for the Excel workbook, what you should be doing for that. Okay, for the Excel workbook, to be honest, there's nothing here for the Excel workbook for this portion. If you wanted to, it wouldn't be a bad idea if you didn't already do the display discrete, to go ahead, because I don't think that I asked you to do the display discrete last time. Go ahead and do this, and it will help you a lot. There's a whole video on this, but what you're going to be doing, displaying discrete data, is let's see here. You come in here and you say, okay, which one of these are discrete variables? In other words, let's see, park location, and should I use a pie or a bar chart or neither? So park location, I would put pie chart. And the reason why I would put pie chart is because I would want to see the parts of the whole. If I want to do a bar chart, I want to compare the frequencies to one another. I mean, you could possibly do both if you want to compare the frequencies to one another, but a lot of times, if you have ordinal data, I would suggest that you use a bar chart. If you have nominal data, I often suggest that you use a pie chart. So specific area inside the park. So again, pie chart, specific ride styles, including thrill, spinning. So this right here is actually neither. And the reason why it's neither is because this is a mess. Okay, this if you go back to the Disney World data, um, ride type all, you can't put this in any sort of pie chart. And let me show you. Insert. So I'm going to do pivot table. And I'm going to say, okay, take all of this information and I want to put it into an existing worksheet and I want to do display discrete and I'm going to do okay. Let's see, ride type all. And it's like, okay, what do you do here? Well, thrill shows up a lot, spinning shows up a lot, slow, it just doesn't work. And so if you go like this, there's literally there's 14 that are just slow and that's all that they are, just straight up slow rides. And so it's a bit of a mess. And so ride type all is a mess. And then these right here, these are all dichotomous. So ride type scary, fast pass, these are all dichotomous variables. And if they're dichotomous, you definitely just want to do pie chart because you want to see, okay, what percent is this, what percent is that. And then specification of age. So this right here, this could be a really either, but let's see, pie chart. I would do bar chart for that. And you can go all the way down. So basically, if it's ordinal data, or has some sort of quantitative aspect to it, I would do a bar chart. If it's a qualitative nominal data, then I would do a pie chart. Okay. Then coming through here, make a pivot table in the area to the right for Disney, from the tab Disney World data, make a frequency table for park area. So we're going to click on park area. And then I'm going to put it in rows, and I'm also going to put it in values. And it should come out right away as count of park area. If it comes out as sum, sometimes it might come out as sum. Then what you need to do is you need to right click on one of these numbers and click it to summarize values as count. Okay. And then coming down here, you'll be able to make a pie chart for park area. Okay. And then we're going to do data. Let's do this pie chart, copy and paste it out of here. And the reason why is because the moment that you change data in a pivot table, so if I ever change anything in here, it'll change everything else. So it'll be a mess. So I'm going to make a pie chart out of this. So insert pie chart. And I'm going to come over here. And this is cool. What I would suggest you do is put these in order from greatest to least, sort. Okay. And so you can put all of these in order like this. And then you can, let's see here, chart design, add chart element, data labels, outside edge. So now we have the count, but now I'm going to click on this and I'm going to say, sorry, my kids are, I don't know if you can hear my son yelling in the background, but he's like yelping. I don't know why. Okay, so just gonna go like this. This is a nice little, it shows the percentages. I would never normally put this much. Normally, if it's only one, you could also do other 4 and then delete these, which that helps a lot. Or so you can make it so that it's even smaller. So then you go all the way around, and then other is 4%. But either way, they're both correct. But that's a pie chart right there. And then make a frequency table for the table TripAdvisor stars. And we're going to get rid of NA. Oops. So we're going to click on NA, and I'm going to filter hide selected items. So I only want these. Okay, so TripAdvisor stars. Make a bar chart for TripAdvisor stars. Insert. Bar chart. Now, so we've got TripAdvisor stars. Okay. And so you'll see 3, 3.5, 4, 4.55. Now, here's the deal. You could, the way that they have TripAdvisor stars set up, this is actually kind of continuous. And so we could, what's that called? Design. We could actually like make this so that it's a histogram. And oops, make it so that these touch each other. But you don't necessarily have to do that. The stars thing is just kind of weird. Because technically you either have 1 star, 2 star, 3 star, 4 star, 5 star. But what they do in TripAdvisor is, they average the stars. And so they got like an average of 2.5 stars or 2.365 stars. And so they make discrete data into continuous data by putting it all together with other people, and then they average it and they use it like numbers, even though it really isn't. And so I don't necessarily agree with the way that they do it, but it's kind of like a socially acceptable thing to do it. Doesn't mean that you should do it. But if you want to do that, what you need to do is make, let's see here, insert. Whoops. Let's do this. Home text. We got to make that into text, and then insert. There we go. So now we've got text, and then we've got 3. And then what you can do right here is you can double click on one of those, and you want the gap width to be 0. And it makes it into a histogram. And so this technically isn't wrong because of the way that they handle it. The other thing that you can do is you can actually make what's called a frequency polygon. So you click on this right here, and you can do insert frequency polygon. And it says count of TA stars, TripAdvisor stars. And so you've got your count of TripAdvisor stars right there, and it's the exact same thing. The only difference is that if you wanted to, you could also have another column. You could have multiple of them overlapping, but with count of TripAdvisor stars, you can't have multiple of them overlapping with it as a histogram. So that's all that I'd suggest you do for what it is that we're doing right now. And then we're going to be displaying continuous data, which is very similar on the next lecture.